Okay, in 15 and 16, we're going to go ahead and try to um, solve for x on these problems. So on number 15, um, here we have our proportion. So proportions are very nice when we're going to solve. We just cross multiply. We have a fraction equaling a fraction. That's how you can tell this is a proportion. As opposed to 16 here, where you have a fraction minus a fraction equals a fraction. So you have three fractions here, or you have two terms on one side and one on the other. This one you cannot cross multiply. So on 15 we can cross multiply. We get x times 8, which is 8x equals, and we've got 5 times x plus 3. We can go ahead and distribute our 5 to both terms, so you get 8x equals 5x plus 15. Now we got a simple algebra 1 problem. Subtract the 5x, which gets you 3x equals 15, or x equals, dividing by 3, you get 5. Okay. Here we check our denominators. Looks like there's no chance that the 5 is going to change into a 0 because there's no variable, and there's no chance the 8 can turn into a 0 since there's no variable. So it means your final answer on this one is x equals 5. And as far as the domain goes, this would be any real number. Okay. There's no restrictions on your domain. Okay. On number 16, so on this one, we cannot, on this problem, cross multiply, as stated just a moment ago. So first thing we want to do is make sure we factor our denominators first. X plus 2 can't be factored. X can't be factored. And here there is a greatest common factor of x, which gets you x plus 2 after you take the x out, which coincidentally are the same as the first two factors. So now we'd like to multiply through by our least common denominator. So I'm going to find my LCD here, least common denominator. In this particular case, the least common denominator is going to need a factor of x plus 2. Okay. It's going to need a factor of x. And if we look at this denominator here, we already have the factor of x and we have the factor of x plus 2. So this is our least common denominator, which we are going to multiply both sides of our equation by. We're going to multiply by x, x plus 2. If it helps to write it for all three here, go ahead and write it for all three. So when you go to do your canceling, you can cancel and show that step. So we multiply our first fraction by our least common denominator. Again, the purpose is to get the denominators to go away. So the x plus 2 cancels, which leaves you with a 2 and an x. So that gets you 2x minus, and the second fraction, the x cancels with the x, which leaves you with x plus 2 times 1. On this one, since it's subtraction, you might want to go ahead and put the 1 there and then write the x plus 2 because we will need to distribute that negative 1 to both terms. And then this equals over here, the xx plus 2 cancels with the xx plus 2, which just leaves you with negative 4. So now we can go ahead and clean this up. We have 2x. Distribute the negative 1, you get negative x minus 2 equals negative 4. Combined up like terms, 2x minus x is 1x, or just x, minus 2 equals negative 4. So then x would have to equal negative 2 when you add 2 to both sides. Okay. Then looking at our denominators, we need to figure out what our domain is. Here, the bad value of x is what would make this equal to 0. So x plus 2 we know cannot equal 0. So that means if we solve that, x can't equal negative 2. So that would be a bad value. X can't equal negative 2. And then for this denominator, obviously x cannot equal 0. So here is your domain. X can't equal negative 2 or 0. So checking our solution, it appears that Negative 2 is not allowed, so that means your final answer on this one, since there are no other solutions to choose from, would be no solution. Okay? So